to record whatever you ask about yesterday question, okay? You got question to ask me means you do your revision. That is good. Okay, can I? Just tell me the question, then I will answer you accordingly. Quick. Yes? Yeah, you just speak it out. Okay, how you determine whether the particle is moving to the left or right? Okay, so can you tell me what is the velocity when t equal to 1 for yesterday? What is the initial velocity? Initial velocity. Okay, so initial velocity, you know what to do? You have to put t equal to 0 and you find the velocity and we get negative 26, am I right? 36, negative 36 cm per second. Okay, when you say negative 36, so that will show you the direction. Okay, so if you want to know which direction the particle is moving, you find the value of the velocity. Okay, now I point to here. So if velocity is negative, then the object is moving to the left. That means if this is a motion diagram, if this is our motion diagram, this is a fixed point. The particle is here initially, so it is moving towards this direction. That is called move to the left. So you want to know whether the particle is moving to the left or to the right at a particular time, you find the value of the velocity. If the velocity value is negative, conclusion, moving to the left. Nothing to do with its position. Are you clear? Okay, set. And is moving to the left with the speed of 36 cm per second. So velocity, hello young man, what happened to you? Yeah, why you tilt your head? May I know? Yeah, Are you listening? Are you looking? Okay. So velocity is a vector quantity. The sign of the velocity tells you the direction. The value of the velocity, the absolute value. Okay, just now your friend asked me about this. So if in maths we have these two lines, we call it absolute value. The two line means absolute value. That means we don't care about the sign. So this will be 36. That will give you the sense of the speed. Speed is a scalar quantity. Clear? Sign give you the direction. Signs of velocity. Please be very specific. Are you talking about velocity, displacement, or acceleration? Got it? Okay, done. Any more question? No. Got. Negative acceleration got. Because acceleration is acceleration is rate of change of velocity, and it is a vector quantity. So acceleration also got negative. Okay, so now acceleration, okay, since your friend talked about acceleration, in our case, for this question, the acceleration is always positive, correct? This means that the velocity of the particle is always increasing. So I can also have a situation example. Do you do example 2? Did you try example 2? No. Okay, you're trying to study example 1. Okay, so maybe we can go to our textbook. Let me have a look at textbook to show you an example of acceleration is negative. Then I will explain to you what does that mean. Okay, can everyone turn to your textbook? Can you tell me which page? Yeah, I think page 79, correct? Let me see. Number 2 is not a good question. 4 is also not a good question. 5 is not. Six also is not a good question. 7, 1 minus 1 over 2t plus 1. Okay. So let's look at question 10. Okay. So everyone, please turn to page 83, question 10. This is a good question to discuss with you. Okay, so I'm going to discuss this question with you. Okay, they said the velocity. Am I at the right exercise? Yeah. Okay, the velocity of an object after t seconds. Okay, this is the velocity function, correct? The velocity of an object, they didn't give you the displacement function. They only talk about velocity. Okay, so the velocity function is this. So 25t e to the power negative 2t. Okay, now use technology to help sketch the velocity function. Okay, everyone, take out your graphic calculator and sketch. Remember, t is greater than or equal to 0. Okay, take out your graphic calculator and sketch. You put your t, you go to window, you put your x minimum as 0, you put your x maximum as maybe 3, then you do a zoom fit. You try and see. You got that? Can you please find the coordinates of the stationary point, the turning point? This is your VT graph. Am I right? Your VT graph look like this. Okay, this point the coordinates will be 0.5. Am I right? The x. Do you get 0.5? You see, I don't have calculator. I memorize it. Memorize this function. Later, I will show you the characteristic of this function. Okay, you got that? Yeah. So how am I going to find the coordinates of this point? Uh-oh, sorry. Then you go like that. So there is an inflection point someplace, somewhere here, correct? So if you want to find the x coordinate of the inflection point of VT, what you need to do? Now, if you put in your calculator y1 as VT, then your y2, which is this. Do you know it will be 80? Rate of change of velocity is acceleration, correct? Yep. Okay. So your acceleration will be 0 at the point 0.5. So this will be your acceleration. This will be your y2 graph. Do you have your y2 graph like that? So this is your y equal to the acceleration. So this will be your acceleration function. So may I know what is the coordinate x of this point? Hurry up. Can you give me the answer? Okay, I will walk around and check. I make sure everyone, your graphic calculator have these two graphs with you. I have to check. If not, you're not practicing using your graph. And then you don't know how to do, then you start to. I exaggerate a little bit. Your whatever shown in your graphic calculator may not be exact. I just show the important feature, right? If you put your x greater than your x maximum is 2, right? The important feature is at around 0 and 2. So actually the 3 is also used. Right? Yeah. Right. So is it 1? X coordinate is 1. Everyone got the graph? Yeah. So that means I know that at t equal to 1, the velocity is decreasing at the fastest rate. Agree? That's how I interpret. Okay, we haven't answered the question yet. So look, so this is 1, am I right? So here is 1. Am I right? So I can make a conclusion like that. Okay, from this graph itself. Okay, I myself have it in mind. Okay, what can I say? Okay. When t equal to 0.5 second, a 0.5 is equal to 0. Agree? Agree or not? Okay, then I can say that v 0.5 is equal to a value is the maximum velocity. Right? That is two things that I can interpret. Are you okay? Okay. Then when t, or you can say at t equal to 1 second. Okay. A1 is equal to a certain value. Okay, I can interpret this is the minimum acceleration. Okay, and I also can make another very important facts about velocity. So V1. Okay, so I will get V1. So that means this is the minimum. So I will say at t equal to 1, velocity is decreasing at the fastest rate. Okay, because that is a non-horizontal inflection point for VT. So you see, when you see a graph, you should know how to interpret. You get me? So for part A, the answer is just the blue color graph. That is what the question wants you to do. Am I right? So now if you look at the red graph, you know that from 0 to 0.5 seconds, the acceleration is positive. After that, the acceleration is negative. So what do you mean by positive acceleration? It means that the velocity is increasing. And if you look at the graph, okay, so now I go to the graph and I interpret the graph for you, how we describe the changes. Can we? Okay. So I go to the next page. I haven't answered all the questions. I try to give you as much as possible from one question. Okay. So if I look at the velocity time graph, so I got the coordinate of this point already, 1 is 0.5. I don't know what is the V, V 0.5, you should know. And I also got this point, there is 1, and I also don't know what is, okay, so look. So when I want to describe the changes of the velocity, there are two critical points for time. That is 0.5 and 1. All right? So I'm going to describe it in this way. So there are 3 intervals altogether. You see the 3 intervals? Okay, so look carefully. For why every time when I come into this class, the way I draw for t between 0 and 0.5. If you want to put equal, also nothing wrong. Second, Vt, that is the velocity, is increasing or decreasing? Increasing. With just telling me increasing is not enough, because the graph will give you certain feature. Increasing with Increasing rate or decreasing rate? Huh? Decreasing rate. Am I right? Still remember I teach you how to talk about concave and convex, concave up and concave down. So when we ask you to describe, you don't just say VT is increasing and stop there. I will not give you full mark. I want to know how it increased so that I can imagine. Because when you say something increase, it can increase like that. This is also called increase. This is also called increase. So which way? This is also called increase. If it's a straight line, I will say increase with a constant rate. So these three, which one are you talking about? You see or not? How important is it, the back one, with what rate? Because the graph, why I say decreasing rate? Because the gradient become less steep. Am I right? Okay, good. Now, for the interval, T between 0.5 and, do you know why Miss Do write the T like that? And not like this? And not like this? Yeah, so that I don't confuse with my plus sign. Thank you. So math teacher are very particular. Okay, and 1. So this part, if you look at the graph, this part, I purposely draw it black so that you can relate. So I will say that Vt, that is the velocity, is increasing or decreasing? Decreasing. With becomes steeper, am I right? So with what rate? Increasing rate. Okay, that means the rate keep increasing until at 0.1. Then the shape changes. So the next part. Okay, my graph, I will draw an arrow here, means it shows that for T greater than 1, Vt is increasing or decreasing. Do you know why, Miss Do, every time when I ask a question, I pause? Do you know why? Do you know why I pause? I don't want to straight away give the answer. I want you to come out with the answer. Whether you want to tell me or don't want to tell me, it doesn't matter. It's in your mind. Then you check with my answer. That is the purpose why a teacher pause. So it's not for you to stop thinking and wait for me. A student, when you are in the class, you must be always thinking. You get me? I don't give the answer because I want you to figure out in your mind. And if you are willing to check whether your answer is right or wrong, please tell me the answer. Okay? So for T greater than 1, Vt is increasing or decreasing? Decreasing. Because it's going down. With decreasing rate. Because the graph become steeper. But will it be 0? Will the rate be equal to 0? No. It will approach 0, but it will never be 0. Are you clear? Okay. Good. So that is how, if the question asks you to, okay, sketch the graph of certain thing and describe the changes of that particular thing. So there are a few critical points. So we call all these critical points. That is turning point, stationary point, and inflection point. Okay, so these are called critical point. Critical means after this point, something different happened. So when you talk about curve, the critical point are stationary point and inflection point. You get me? Are you okay? This is not the answer, okay? This is the extra. I teach you how to describe if the question. Okay, so Dana, so use technology to help sketch the velocity function. Okay, you sketch already, huh? So I'm going to tell you there are important features that you must put. You must put down the coordinate of the stationary point. That is the minimum. If I ask you to sketch the graph, if there is any stationary point, turning point, you better jot down the coordinates because your graphic calculator can help you to do so. It won't take much of your time. Without that, if I give you sketch graph with 2 marks, I only will give you 1 mark. Are you clear? Stationary point is a must. And if I give you a certain range of t, so you must tell me the coordinate of the starting point and the ending point. Get me? In order for you to get full 2 marks. So may I know what is the coordinate? What is V 0.5? Can someone tell me? Can someone tell me what is the answer? 4.6. Okay, 4.60. 3 significant figure. Are you clear? So that will be part A. Okay, so answer for question 10, part A. Okay, now to do part B. Show that the object acceleration at time t is given by this. Okay, so when you do this, you have to use what? No, you have to use products rule. Why I say products rule? Because your VT is made up of products of 2 functions. One is the linear function. The other one is an exponential function. So can you please use your products rule and work it out now? So your U will be 25t. Your V will be e to the power negative 2t. Okay, please differentiate this. Okay, we try not to use U and V because we are dealing with velocity. M and N. Okay, you like M and N chocolate. Okay, M and N can, no problem. So we use M and N. Why I choose to use M and N? Because V is for velocity in this case. Can or not? So we have to be very careful with the symbol that we use. Okay, M prime is 25. N prime is when you have exponential term, you copy down the whole thing, then time by the derivative of the power. Okay, now you substitute it into the formula. Cross and plus. Cross, multiply, and plus. That is how I remember. That will be the easiest. Okay, so it will be e to the power of negative 2t times 25 plus 25t e to the power negative 2t times negative 2. Okay, whatever you do when you talk about max, the next step is underline the common factor. Underline the common factor. So if any terms that everything you underline, you have to remind yourself. This means 1 times. That is, you yourself have to remind yourself. So I factorize out. So this is my AT. 25 e to the power negative 2t, open bracket 1. Here you have negative 2, here you have t. So minus 2t. That's it. Are you clear? Okay, good. So that will be our part B. So now, when is the velocity of the object increase? So if you look at the graph, you should know, am I right? You can answer the question already. When? Increase. So my answer for C is, when is the velocity of the object increase? T greater than or equal to 0, but less than or equal to 0.5. Answer. Second. Okay, when is the speed of the object decreasing? I told you already, if you want to know the speed, increasing or decreasing, how many sign diagram must you have? 2. One is the velocity sign diagram. If you look at the graph, the only time that the velocity is equal to 0 is at the beginning, am I right? After that, will the velocity become 0? No. So, and the whole velocity time graph is above the x-axis, correct? So, the velocity is always positive. So, what do you mean by the velocity is always positive? That means the object is always moving to the right. It never turns, right? And you will never stop. You will never stop. It will keep moving to the right. It never stop moving, correct? Because the velocity never becomes 0, only at the beginning. It starts from 0, then it just go on and on. Okay, so acceleration. Okay, acceleration sign diagram. Acceleration is the rate of change of velocity, correct? When the rate of change of velocity equal to 0 at its highest point, that is 0.5. Am I right? So I mark that. So from 0 to 0.5, the rate of change of velocity, is it positive or negative? Positive, because it's going up. After that, the velocity is decreasing. So acceleration is negative. In physics, if you have negative acceleration, you will say deceleration. Correct? So is it possible for the acceleration to be negative value? Yes. When the acceleration is negative, it means that the velocity is decreasing. Does it mean that the speed is decreasing? Not necessary. Okay, so now the question says, when is the speed of the object decreasing? So which region must I select? The one to the right. Opposite sign. That means I must select this region, opposite side. So therefore, conclusion, speed decreasing when t is greater than 0.5 second. Agree? So if I turn this question into your SAT, I ask the other way around. When is the speed increasing? Then you will tell me same sign. That is from 0 to 0.5. Am I right? Okay, so don't take kinematic as something that is very difficult. There is no choice. You have to know how. If I want to find this, I must have this. If I want to find this, I must have this. So I give you one whole weekend to go and consolidate all. I don't think is too much. Am I right? Please do your practice from this exercise, and also the one, there's another one example, correct? That example is describe different thing. Yep. Okay, any more question? You still have 5 minutes. Those online,